Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion on the channel of Vyas Edification, we are discussing mathematics, class 11th, and the chapter that we are dealing with is trigonometric functions. Today is the turn of the lovely miscellaneous exercise. The complicated affair of miscellaneous will be dealt over here with you. Let's discuss the first question. The question says that prove that 2 cos pi by 13 cos 9 pi by 13 plus cos 13 pi by 3 pi by 13 plus cos 5 pi by 13 is equal to 0. This sum overall, mind you, there is a product over here, right? So, on seeing this question, the first thought that comes to mind is that we need to apply some kind of a transformation, right? Some kind of a transformation, yes. This product can be converted into a sum or difference, right? And or this sum could be converted into a product maybe, right? This is cos c plus cos d, which can be done as 2 cos c plus d by 2 cos c minus d by 2, and maybe it will be equal to that. What else? We could also think in other terms, and we can probably write this 2 cos pi by 13 cos 9 pi by 13. Imagine this is 2 cos a cos b. This is 2 cos a cos b, which can be done as cos of a plus b plus cos of a minus b, right? So 2 cos a cos b, yes, this can be done as cos of a plus b plus cos of a minus b. This can be done as this. Right. Using this, we can simplify this first term over here in the LHS. Since we have to prove, let's begin with the LHS. Let's begin with the LHS, yes. And in the LHS, you have 2 cos pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 cos 5 pi by 13. Okay. This is 2 cos a cos b. 2 cos a cos b will be converted to cos of a plus b. A plus b is actually 10 pi by 13 plus cos of a minus b. What is that? A minus b is pi minus 9 pi or 9 pi minus pi. Anything can do, because cos minus theta is equal to cos theta, right? We are not supposed to worry about that. This is 8 pi by 13 over here. Okay. Plus cos 3 pi by 13 is okay, and cos 5 pi by 13 can be written as it is. What next? Once we have reached this stage, what next? The next thing that you are going to do is, can you see that this is 10 pi by 13 and this is 3 pi by 13? The angles when added together would be equal to 13 pi by 13, which is pi, right? Okay, so this 10 pi by 13 can be written as cos of pi minus 3 pi by 13. And what's the use of that? Can you observe? Cos of pi minus theta is minus cos theta. So this will become minus cos 3 pi by 13. There's a plus cos 3 pi by 13, they will get cancelled, right? Similarly, do you observe that this is 8 pi by 13, this is 5 pi by 13, add the angles together, what you get is 13 pi by 13. 13 pi by 13, yes, and which is actually pi. So therefore, this can be written as cos of pi minus 5 pi by 13, which is simple, plus cos of 3 pi by 13 plus cos of 5 pi by 13. This is what you have. On observing this, I can write this as minus cos of pi minus theta is minus cos theta. Cos of pi minus theta is minus cos theta. Plus cos of 3 pi by 13 is already there, and cos of 5 pi by 13 is also there. Right? This is 5 pi by 13. Okay. Observe this carefully. Cos 3 pi by 13. This and this get cancelled, and this is equal to 0. This here is equal to 0. Okay. This is what we wanted, right? And yes, this is equal to the RHS, hence proved. Hence proved. That's a complete solution for this question over here. Let's discuss this question next. What does the question say? Prove that this plus this is equal to 0. Okay. How do we go about proving this? So we can simplify this LHS, right? This LHS is pretty complicated. It looks pretty big. What do we have in the LHS? Let's take a look at this carefully. Sin 3x plus sin x times sin x, cos 3x minus cos x times cos x. That's what we have, right? One of the ideas that comes to the mind is, why not apply sin c plus sin d over here? Why not apply cos c minus cos d over here? That's something which we can do. But then there's another idea that comes to the mind. This one idea I'll discuss, but this is, let us call that method 2. Let's see another method which is a simpler idea, right? Without using transformation as well. How's that? This sin 3x can be multiplied with sin x, right? What you get is, this is sin 3x times sin x. Okay. This sin x and sin x can get multiplied together, right? Yes. And what you get is, this is plus sin square x. What about this? Cos 3x and cos x can get multiplied together. This is cos 3x times cos x. And minus cos x will become minus cos square x. Yes or no? This is what you get. Is that okay? Yes, this is pretty simple. Now, cos A cos B plus sin A sin B, what is that equal to? Cos A cos B plus sin A sin B is cos of A minus B. This becomes cos of 3x minus x. This whole can be simplified as this. And this is plus sin square x minus cos square x. Can you imagine? Can you see that this is negative of cos square x minus sin square x? Okay. So, what you have over here is, let's take a minus common and this becomes cos square x minus sin square x. What is this? This is cos 2x. Yes. What is that? That's another formula for cos 2x, right? Now, what is this equal to? This is cos 2x minus cos 2x, which is simply 0. Yes. And this is what we have in the RHS. That's a complete proof of this. Yes. But you talked about another method. Yes, we talked about another method. And let's see the method 2 that we can use, which uses the transformation formulae. How do we use that, right? Let's see. Once again, we begin with the complicated version, which is in the LHS. And what do we do after that? I want to apply the transformation of sin 3x plus sin x. Okay. And sin 3x plus sin x is similar to sin c plus sin d. What is sin c plus sin d equal to? Sin c plus sin d is 2 sin c plus d by 2 cos c minus d by 2. Okay. Let's apply that. Sin 3x plus sin x is 2 sin c plus d, that is 3x plus x by 2, cos c minus d, which is 3x minus x, times, you already have a sin x over there. Let's keep it at this. What about cos 3x minus cos x? This is cos c minus cos d. Now, what is cos c minus cos d equal to? This is minus 2 times sin of c plus d by 2. Again, sin of c minus d by 2, right? So, you have both, at both places you have sin. Minus 2, okay, there's a plus, that it becomes minus 2 sin c plus d by 2, which is 4x by 2, okay. And you have sin c minus d by 2, which is 3x minus x, 2x by 2, okay. And you have a cos x already there. Now, what does the LHS simplify into? Let's see this. This is 2 times sin, this is 2x. What is this? This is cos x. What is this? This is sin x. What about the remaining thing? This is minus 2 times sin 2x, okay. You have a sin x and then you have a cos x. Do you observe that these two terms obtained are exactly same, right? There is sin 2x, there is a cos x, there is a sin x, sin 2x, cos x, sin x. This overall is equal to 0, which is equal to the RHS, and that's the complete proof for this question over here. As you can see, this is using method 2. Let me get aside so that you can take a look at both the methods once again. And this is all in this question. Let's try and solve this question next. What does the question say? Prove that cos x plus cos y whole square plus sin x minus sin y whole square is equal to 4 times cos square x plus y divided by 2. What to do in this one? So, we have a long and complicated expression on the LHS, whereas in the RHS we have a simplified expression, right? So, the target is to first simplify the LHS. Let's begin with the LHS in that case. Left hand side, what do we have in the LHS? We have two terms and squaring of those terms, and here you have a single term, okay. So, how can I simplify these terms over here? Let's take a look at that. Once again, there can be two approaches of solving this. One is a simple approach which uses least application of the brain. Let's see that approach first. What I can do is, okay, cos x plus cos y whole square, I cannot do much with this. What I can do is I can simply square that first of all, right? But then, without squaring also, what you can do is, you can maybe use cos c plus cos d on this, right? That's something we shall talk about later. Let's square this first. This is cos square x. Why am I squaring? Because I see a cos square x and simultaneously I see sin square x as well. So, cos square x plus cos square y plus 2 cos x cos y is what I observe. Then you have sin x minus sin y whole square, which will be sin square x minus plus sin square y minus 2 sin x sin y. This is what you get, right? What to do about this? There is a cos square x and there is a sin square x. Let's add them together. What you get is a simple one. There is a cos square y, there is a sin square y. Let's add them together. What you get is again 1. What else? From these two terms, you can take a factor of 2 common, and what remains is cos x cos y minus sin x sin y. Cos a cos b minus sin a sin b. What is that equal to? That's equal to cos of a plus b, right? Remember that. This is cos of x plus y. Oh, you have written that directly. Yes, I can write that directly, right? We can take a factor of 2 common, cos x cos y minus sin x sin y, which will be cos of x plus y. Okay. This is a 2. This is 2 times cos. I can take a 2 common. What I get is 1 plus cos x plus y. Okay. This is 2 plus 2 times cos of x plus y. Can you please note that? Yes. Once you have noted that, what next? I see 1 plus cos something, and you see on the RHS you have that same angle, but that one has been combined together and you have converted this x plus y into x plus y by 2. Half angle, right? Yes. So we'll consider some half angle formulae. Yeah. What's the half angle formula that we want to recall? You remember 1 plus cos 2 theta is equal to what? This is 2 cos square theta. Whereas 1 minus cos 2 theta, let me recall this formula as well, right? This is equal to 2 sin square theta. You should remember these formulae, right? Here we'll require only this one. Only the above one, right? Here we only need this one, but I've written both of those versions, right? Let's see. 2 times, what does this convert into? This is 1 plus cos 2 theta. You get 2 times cos square theta by 2, which is x plus y divided by 2. This is what you get. What does this convert into? This is 2 times 2 is 4 cos square x plus y whole divided by 2, and this is exact same thing that you wanted there. That's a complete proof using this approach. Do we have another approach? Yes, we have another approach. Using transformation formula. Let's use transformation formula. Once again, LHS seems pretty complicated. Let's simplify that. We have, observe this carefully, this is cos x plus cos y. Imagine this is cos c plus cos d, which is 2 cos c plus d by 2 cos c minus d by 2. This will become cos x plus cos y, 2 cos x plus y by 2 cos x minus y by 2. And there is a whole square over here. Okay. What else? Sin x minus sin y. Sin x minus sin y. This is 2 cos x plus y by 2. Cos will come first and sin term will go back to back. 2 cos x plus y by 2 sin x minus y by 2. And this here is the important step, right? Once you have written this much, do you observe? This becomes 4 cos square this, 4 cos square this, sin square this, right? There are 2 terms. Yes, I see a 4 in both and I see cos square x plus y by 2 in both. Okay. So let's take them common. Yes, let's take them common. Out. What remains is cos square x minus y whole divided by 2. What remains here is sin square x minus y whole divided by 2. Oh, okay. What's that thing in the bracket? Do you observe that these two angles are same? This is cos square theta plus sin square theta, which is obviously 1. And this becomes 4 times cos square x plus y whole divided by 2. Is that all? Yes, that is all for this question. That's a complete proof using all of these ideas that we have learned. Using transformation, using some other multiple submultiple angle formula, right? This is the final solution for this question. Is that all? Yes. Let's try and see this question. Cos x minus cos y whole square plus sin x minus sin y whole square. What are we supposed to do in this one? Let's try to use transformation. We can solve using transformation, or we can also solve by squaring first, right? Let's use transformation this time. In the previous question, we have seen 2 methods. Let's see one of those. Let's use transformation in this one. What do we have in the LHS is cos x minus cos y whole square. What is cos x minus cos y equal to? This is cos c minus cos d, which is equal to minus 2 times sin c plus d by 2 sin c minus d by 2. This will have 2 sin terms. Minus 2 times sin x plus y by 2 sin x minus y by 2. And you have a whole square at the top. What about the other term? Sin x minus sin y whole square. Let's see that. This is sin c minus sin d. What is that? 2 cos term will come in the front. 2 cos x minus y by 2 sin x plus y by 2 sine x minus y by 2, right? Cos of x plus y by 2 and then sine of x minus y by 2. You have a whole square after that, right? This is what you have. This becomes 4 sine square x plus y by 2. This is sine square x minus y by 2. Then you have a plus, and after that you have the next term. What is that? 2 square is 4. This becomes cos square x plus y by 2, and this becomes sine square x minus y by 2. What next? Do you see something coming out common from both of these terms? I have a 4 which is coming out common. I also have a sine square x minus y by 2, sine square x minus y by 2 which can come out common. And then what remains is sine square x plus y by 2 from here. And what about that term? You have a cos square x plus y by 2 remaining over there, plus, oh, this is pretty simple. Now what I observe is sine square theta plus cos square theta. These angles are same. Sine square theta plus cos square theta, simply 1. 1 is in the product, that will remain as it is. This is 4 times sine square x minus y by 2, and yes, this is my RHS. This is my right hand side, right? This is equal to right hand side. It's complete proof for this question. Do we have another approach for this? Yeah, a simpler another approach. Simpler? This is pretty simple. Another simple approach could be using method 2. What do you have? In the LHS, let's square these terms. What do you have is cos x minus cos y whole square. A minus b whole square is a square plus b square minus 2ab, right? This is cos x minus cos y whole square, which will become cos square x plus cos square y minus 2 cos x cos y. This is what you have, right? What next? Sin x minus sin y whole square. Let's write that again by squaring. This is sin square x, first term, plus sin square y minus 2 times sin x sin y. Okay. Now what is this cos square x plus sin square x equal to? This is simply 1. This again is simply 1. This is minus 2. Let's take out a minus 2 common from these two terms. This becomes cos x cos y plus sin x sin y. Now cos x cos y plus sin x sin y will be equal to cos of x minus y, right? You have a 2 over here, okay. You have a 2 cos of x minus y over here. Let's take that 2 common. 1 minus cos of x minus y remains, okay. And I can transform this using half angle formula, right? I can transform 1 minus cos 2 theta in terms of sin square theta. This is 2 times 2 sin square half this angle, which is x minus y by 2, yes. And observe this, this is, what is this? 2 times 2 is 4, 4 times sin square x minus y by 2, which is the RHS. That's a complete proof for this question using another approach, right? That's a complete solution for this question. Let's try and solve this question next. What does the question say? If you observe the LHS has many terms separated by plus signs, right? And on the RHS you have product of a lot of terms. So what you are simply doing over here is using transformation formula of converting sum into product. Okay, let's do that. For transformation you need 2 terms, right? And which 2 terms do you think? Should we use these, club together these 2 terms and these 2 terms? Why? Why not club together this with this and this with this? So in the LHS what I have is, observe, in the LHS what I have is sin 7x plus sin x, this is one term, plus you have sin 5x and sin 3x. Let's write them again. Sin 5x plus sin 3x. This is what you have. Alright. And what is sin c plus sin d equal to? Now sin c plus sin d is 2 sin c plus d by 2 cos c minus d by 2. Remember that. Sin c plus sin d is 2 sin c plus d by 2 cos c minus d by 2 plus the other term. Once again we have a sin c plus sin d, which is 2 sin c plus d by 2, okay, and cos c minus d by 2. This is what you have. Is that okay? Yes. I observe that 2 and 2 are common in these terms. Even sin 8x by 2, sin 8x by 2, which would be sin 4x, is common. Let's take that out common. 2 times sin 4x, I take it out common. What remains is, this is cos 3x plus what remains there is cos x, okay. Again we can apply transformation on this because there is no plus sign over there, right? We'll have to convert this also into product form. Let's do it. This is 2 sin 4x is okay. Cos C plus cos D. Cos C plus cos D will be all cos. 2 cos C plus D by 2. Cos C minus D by 2. 2 cos C plus D by 2. Cos C minus D by 2. This is what you get. And what does this simplify into? 2 into 2 is 4. This is sine 4x. Okay, this is cos 2x and this is cos x. And what about the RHS? What does the RHS look like? RHS looks like you have a 4, you have a cos x, cos 2x and sin 4x. 4, cos x, cos 2x, cos sin 4x, all in product. Yes, this is my RHS. That's a complete proof of this one. Is that all? Yes, that's all in this question. Let's move on to this question next. What does the question say? We have huge expressions in the LHS. Huge expressions, yes, huge looking, big expressions. But if you remember the transformation formula, you would realize that this can be converted into a product. This here can be converted into a product, simplified, right? This can be simplified, this can be simplified. Instead of having these huge terms, 2 terms in the numerator, 4 terms in the numerator and 4 terms in the denominator, we'll have is 2 terms in the numerator and 2 terms in the denominator. Further, we may be able to apply a transformation formula on the remaining as well, right? Who knows? Let's try to approach the LHS using that idea. What do you have? We have sin C plus sin D. Sin C plus sin D is equal to, you have a sin C plus D by 2, cos C minus D by 2 and 2, a factor of 2. This is 2 sin C plus D by 2, cos C minus D by 2, okay. Plus, what you have over here is sin 9x plus 3x, 2 sin C plus D by 2, cos C minus D by 2. This is what I have. What do you have? Is that okay? Yes. What you have in the denominator is simple. Cos C plus cos D. What's that? Cos C plus cos D is 2 cos C plus D by 2. Cos C minus D by 2. Plus what next? This is again cos C plus cos D, which is 2 cos C plus D by 2 and cos C minus D by 2. The angles are similar, right? That's what you have. Is that okay? Yes. What do we observe in the numerator is 2 and 2 are same. Sin 12x by 2, sin 12x by 2 are same. They will come out common. This is 2 sin 6x comes out common. Can you observe that? Yes. What remains is cos x plus what is there? Cos 3x. Okay. What about the denominator? In the denominator you have 2 cos 6x here. 2 cos 6x here as well. Okay. They will come out common. What remains is cos x plus cos 3x. Oh, pretty interesting. These two terms are exactly same. They will get cancelled, right? 2 and 2 will also get cancelled. This is sin upon cos tan 6x. Is that simple? Yes, that's pretty simple. Tan 6x, which is equal to the RHS, hence proved. Which is equal to the RHS. That's a complete proof. Is that all? Yes. Let's try and solve this question next. What does the question say? Prove that. You have a lot of expressions, a lot of huge expressions on the left hand side, but they are all separated by plus or minus sign. Whereas on the right hand side, you don't have any plus or minus, they are only products, right? So we'll have to actually convert the sum or difference into product using transformation results, right? Let's do that. In the LHS, I have sin 3x plus sin 2x. Okay. You have 3 terms, right? We can combine any 2. Let's combine these 2. Plus, what do you have? Sin C plus sin D is 2 sin C plus D by 2. Remember that. Sin C plus sin D is 2 sin C plus D by 2 cos C minus D by 2. C minus D by 2. Okay. Minus. What about the sin x? Can you observe that we would have wanted to take out something common. But then seeing these two, I cannot take out anything from sin x until unless I write sin x in terms of x by 2. Right. Sin 2 theta. Remember that sin 2 theta is equal to 2 sin theta cos theta. Let's use that. Sin x will be 2 sin x by 2 cos x by 2. Okay, seeing this, what you observe is this is 2 cos x by 2 cos x by 2 will come out common. And what remains is sin 5x by 2 minus sin x by 2. This is what remains in the bracket. Sin x by 5x by 2 minus sin x by 2. This is 2 cos x by 2, which is okay. Sin c minus sin d. Sin c minus sin d is 2 cos c plus d by 2. Now observe c plus d. C plus d is 5x by 2, x by 2, which is 6x by 2. Right? This is 2 cos c plus d by 2. sine c minus d by 2. What is c minus d? 5x by 2 minus x by 2 is 4x by 2. This is what you have. Is that okay? Yes. This is 2 times 2 is 4. There you have a cos x by 2. There you have a cos 3x by 2. And then you have a sine x. Then you have a sine x. So you have 4 sine x, which is okay, cos x by 2, which is okay, and cos 3x by 2, which is also okay. This is same as the RHS. And is that all? Yes, that's all. That's the complete proof for this question over here. Let's try and discuss this question. What does the question say? Find sine x by 2, cos x by 2, tan x by 2 in each of the following. We are given tan x equals minus 4 by 3 and x lies in quadrant 2. Okay. How do we go about solving this? Let's see the question. Tan x equals minus 4 by 3. Okay. And x lies in quadrant 2 will imply that quadrant 2 will imply that x is greater than pi by 2 less than pi. Right. Quadrant 2. This is from quadrant 2 implies that x lies in this interval. Okay. What about x by 2? X by 2. X by 2 will be greater than pi by 4 and less than pi by 2. Can you observe that? Yes. So x by 2 will lie in the first quadrant. Can you observe that? Yes. This is less than pi by 2. Remember the quadrants? Yeah. This is 0. This is pi by 2. This is pi, this is 3 pi by 2, this is again 2 pi, right? That's what you have. So second quadrant implied that the angle lies from pi by 2 to pi, yes. And division by 2 implied that x by 2 would lie between pi by 4 and pi by 2. Pi by 4 is somewhere here, pi by 2. So this is the line pi by 4 in this interval. This is the region in which x by 2 will lie, okay. Now given tan x equals minus 4 by 3, do I have some relation between tan x and any of these? Yes, I have a simple relation between tan x and tan x by 2. Can I use that relation? Yes. What is the relation? Tan x equals 2 tan x by 2 over 1 minus tan square x by 2. I have a simple relation, direct relation between these two. Let's use that. Since tan x equals this gives me 2 tan x by 2 over 1 minus tan square x by 2 is equal to tan x. Tan x is minus 4 by 3, as you can observe. On substituting this, do you observe that you have a single variable in this equation, that is tan x by 2. Can you find the value of tan x by 2 for me? Yes. So let's simplify this. We'll get rid of this one over here. And let's simplify this. What you get is 3 goes over here. This becomes 6 tan x by 2, which is equal to minus 4 times this, which is minus 4 plus 4 tan square x by 2. This is what you get, right? Let's try to solve this quadratic. This is 4 tan square x by 2 minus 6 tan x by 2 and minus 4 in the RHS over here. This is what you have. We can divide by a factor of 2. We can divide by a factor of 2. And is there anything else? Yes. 2 tan square x by 2 minus 3 tan x by 2 minus 2 is equal to 0. 2 times minus 2 is minus 4. This can be this. We can split the middle term to get the roots. This will become minus 4 and plus 1, right? Tan x by 2. This is 2 tan square x by 2 minus 4 tan x by 2 and plus tan x by 2 minus 2 equals 0. Do you observe this? Yes. After reaching this stage, you can observe that one of the factors tan x by 2 minus 2 will come out common. The other factor is 2 tan x by 2 plus 1, which will be equal to 0. This is what you get, right? 2 tan x by 2 will come out common from here, from these two terms. What remains is tan x by 2 minus 2, same as this. 2 tan x by 2 plus the other factor 1 will come out over there. Therefore, the value of tan x by 2 that I obtain is 2, or tan x by 2 is equal to minus 1 by 2. Now mind you, x by 2, we already remember that x by 2 lies in the first quadrant. Since it lies in the first quadrant, negative value will not be accepted, but this positive value will be accepted. And we reach tan x by 2 is equal to 2. We reach, therefore, let me get rid of all of this. Let me get rid of all of this, except for the fact, do not remember anything except for the fact that x by 2 lies in the first quadrant. So therefore, tan x by 2 is equal to 2. That's the first thing. And after this, what you can do is simply draw a triangle, and you can find sin x by 2, cos x by 2 very easily. But when we want to solve analytically, what are we supposed to do? Drawing a triangle is pretty simple. This is something which you can do in the rough. Tan x by 2, if this angle is x by 2, 2 over 1 is this value 2. This will become root 5, and sin x by 2 will become 2 by root 5. Cos x by 2 will become 1 over root 5. That's pretty simple, right? That's pretty simple. The values will be positive since x by 2 lies in the first quadrant. But using analytical approach, what do I have over here is sec square x by 2. I will relate this with another trigonometric function. Sec square x by 2 is equal to 1 plus tan square x by 2. And with the help of this, I can find cos x by 2. Let's do that. 1 plus 2 square is 5. So you have sec square x by 2 is equal to 5, implies sec x by 2 will be equal to plus or minus root 5. Now which value will you consider over here? X by 2 lies in the first quadrant, therefore sec x by 2 is equal to root 5 only, the other value is rejected. Since x by 2 is less than pi by 2 greater than pi by 4, that is in the first quadrant, right? Using this idea. Once you're through with this, sec x by 2 is root 5 implies cos x by 2 is pretty simple. Cos x by 2 is 1 over root 5. Oh, but this is what we obtained over there. Yeah, that's what you obtained. You have already obtained this in the rough. Cos x by 2 is 1 by root 5. This is using analytical approach. What next? What about sin x by 2? Can I find sin x by 2 as well? Yes. Tan theta is sin theta upon cos theta. So sin theta will be tan theta times cos theta. Tan x by 2 is 2. So cos x by 2 is 1 by root 5. 2 over root 5. This is the value of sin x by 2. Is that okay? Yes, sin x by 2, tan x by 2 and cos x by 2. This is what I obtained, right? This is a complete solution that's done, but we could have started in another way. Maybe somebody would like to start in another way, and that is instead of beginning with tan x and finding tan x by 2 first, we may want to convert this tan x in terms of cos x first, and then apply cos x by 2 formula and maybe get the same result using a different approach, right? We'll see in another question maybe the approach using cos 2 theta, but for now this is sufficient. Let's see this question. Cos x is equal to minus 1 by 3. Now here we can use approach of cos x by 2. Let's see. Sin x by 2, cos x by 2, tan x by 2 have to be found for this where x lies in the third quadrant. Now third quadrant implies this is 0, this is pi, this is pi by 2, this is pi, this is 3 pi by 2, this again is 2 pi. So in the third quadrant, this is what we are talking about, implies x is less than 3 pi by 2 greater than pi, and this implies that x by 2 will be less than 3 pi by 4 greater than pi by 2. Observe this carefully. X lies in the third quadrant, pi to 3 pi by 2 is the value of x. In case of x by 2, you get pi by 2 and 3 pi by 4. Now pi by 2 to 3 pi by 4 is this line over here, right? So this x by 2 will lie in the second quadrant. In the second quadrant, sin x by 2 will be positive, cos x by 2 and tan x by 2 will be negative for sure. Remember that. We can begin with cos x equals minus 1 by 3. Cos x equals minus 1 by 3. And use formula of half angles. Formula of half angles. What is that? Cos has many formulae, right? Let me write a few formulae over here. We know that 2 cos square x by 2, or you can simply say 2 cos square theta is 1 plus cos 2 theta. Also you can say that 2 sin square theta is equal to 1 minus cos 2 theta. Let's use this. 2 cos square x by 2, half angle of this, will be equal to 1 plus cos x this, which is 1 minus 1 by 3, which is simply 2 by 3. Therefore, cos square x by 2 is equal to 1 by 3. This is what I get. implies cos x by 2 will be equal to 1 over root 3 or minus 1 over root 3 plus or minus this value. Which value will you consider? Remember, x by 2 lies in the second quadrant. In the second quadrant, sign is positive but cos is negative. So this value will be rejected. This value would be accepted since x by 2 lies in the second quadrant. Cos x by 2 will be negative. This gives me cos of x by 2 is equal to minus 1 over root 3. That's the value of cos x by 2. Now, once you have used this formula once, can I use this formula to get the value of sin x by 2? Yes, let's use this. 2 sin square x by 2 will be equal to 1 minus cos x. Okay, this will become 1 minus 1 by 3, which will be 1 plus 1 by 3, which is 4 by 3. Okay, let's write the value of sin square x by 2, which is equal to 2 by 3. This 2 comes in the denominator, this becomes 2 by 3. And from here you can note that sin x by 2 is equal to under root of this, under root of 2 by 3 or minus under root of 2 by 3. Now which value will you consider? In the second quadrant, sin x by 2 is positive. So this value is okay, this value is not okay. This value is okay. So we have found cos x by 2 and we have found sin x by 2. Time to find the value of tan x by 2 as well. Let me get rid of this whole thing over here. Tan x by 2 will be very simple after this. Tan x by 2 is sin x by 2 over cos x by 2. What is this? Sin x by 2 is square root of 2 by 3 whole divided by minus 1 by square root of 3. You see that square root of 3 in the denominators will get cancelled. This becomes minus square root of 2. Tan x by 2 is equal to this. That is my answer for this question. Right? That's all in this question. Let's discuss this question next. What does the question say? Sin x by 2, cos x by 2 and tan x by 2 have been found, wherein it is given that sin x is equal to 1 by 4. X lies in the second quadrant. Now what happens in the second quadrant is this is 0, this is pi by 2, this is pi, this is 3 pi by 2. In the second quadrant we have these 2 points. X is less than pi, greater than pi by 2. Okay. What about x by 2? Since we also require x by 2, x by 2 will be less than pi by 2, greater than pi by 4. This is what happens over here. X by 2 lies in the first quadrant. This is pi by 4, this is pi by 2, x by 2 lies over here in the first quadrant, whereas x lies in the second quadrant. Okay. So for x by 2 you can observe these three values will all be positive. Okay. What about sin x equals 1 by 4? If sin x is equal to 1 by 4, can I relate this sin x to any of these trigonometric functions directly? You may observe that it's not easy. Sin x by 2, cos x by 2 and tan x by 2, there is no direct result. But I can convert this sin x in terms of cos x, and that cos x can be related to this. So let's do that. Cos square x is equal to 1 minus sin square x. Okay, this is 1 minus 1 by 16, which becomes 15 by 16. Can you observe this? And therefore cos x becomes square root of 15 by 4. Let me write it as square root of 15 by 4 or minus square root of 15 by 4. Which of these values will you consider? X lies in the second quadrant. Sin x is positive but cos x will be negative. This is okay, this is not okay. So from here I get the value of cos x first. Therefore cos x is equal to minus square root of 15 over 4. But were we asked cos x? No, we were asked to find cos x by 2, sin x by 2 and tan x by 2. Remember the formulae for cos 2x. 1 plus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is 2 sin square theta. Right? Right? Let's use those formulae. So, therefore 2 cos square theta is equal to 1 plus cos 2 theta, which implies cos square theta is equal to 1 plus cos 2 theta upon 2. Implies cos square x by 2 over here. X by 2 is what you are interested in and x is what is given to us. 1 by 2 times 1 plus cos x. What is that? 1 by 2 is okay. 1 plus cos x. 1 plus this is 1 minus root 15 by 4. This is what you have, right? This is what you have. This gives me cos x by 2 will be equal to under root of that. Okay. What you have over here is 4 minus, let's simplify that. 4 minus square root of 15 over 8 is what I have over there. Please note that. 4 minus square root of 15 over 8. And we take the under root, we take the plus or the minus. Cos x by 2 is equal to plus or minus this. Okay. Now, since x by 2 lies in the first quadrant, obviously the positive value will be considered, negative value will be rejected. Therefore, cos x by 2 is equal to what? Plus square root of, okay, let's write the simplified version. 4 minus square root of 15 over square root of 8, which is 2 root 2. Right? This is what you get. Obviously, we can multiply and divide by raised root 2 by rationalizing this denominator. This root 2 will get over, can be multiplied in the numerator and denominator. What you get is inside the root you will get 8 minus root 30. That's what you get. Cos of x by 2. Without rationalizing, this is the answer, right? This is cos x by 2. What about sin x by 2? We can find sin x by 2 as well. X by 2 lies in the first quadrant, remember that. And with the help of that cos x, we can find sin x by 2. Let's do that. Sin square theta is equal to 1 minus cos 2 theta by 2. Since we know this. So implies sin square x by 2 will be equal to 1 by 2 is okay. 1 minus cos x is what you'll have. This is what you have, right? Instead of theta, I have written x by 2. Cos x is minus root 15 by 4. This is 1 by 2. 1 plus root 15 over 4 is what you get. Right? Please note this carefully. What next? This gives me sin x by 2 is plus or minus square root of a huge quantity. What is that? This is 4 plus square root of 15 whole divided by 8. Do you observe this? Yes. And which value will you consider? Will you consider the plus value or the minus value? We know that x by 2 lies in the first quadrant, therefore we'll consider the first value, plus value. Sin x by 2 is equal to plus square root of 4 plus square root of 15 divided by 2 root 2. We can multiply and divide by root 2 to rationalize this denominator as well, but then leave the answer at this stage as well. Once you have done this much, what next? Cos x by 2, sin x by 2 are okay. What next is tan x by 2. Let's find tan x by 2 as well. Rationalization is something which you can do on your own, right? Next, tan x by 2 is sin x by 2 over cos x by 2. Okay, what does that become? This is plus square root of 4 plus root 15 upon 2 root 2, and upon 2 root 2 will get cancelled. This is root of 4 minus root 15. Okay, this is what I get. Looks pretty complicated to me. Let's simplify this, and here I will rationalize this complete expression. Let's try and rationalize this. What do I have? What do I get over here? This is 4 plus root 15, this is 4 minus root 15, but both are in the under root. So let's multiply it with 4 minus root 15 first of all. First of all, let's multiply it with 4 minus root 15 square. So what you get is under root of 4 plus root 15, under root of 4 minus root 15 over, this is 4 minus root 15. That's the first step that I apply, right? Okay, you want to remove the root. Instead of removing the root, we could have moved in this direction also. We can multiply with the conjugate of this quantity in the denominator, which is 4 plus root 15. Let's do that. Under root of 4 plus root 15. What do you get? This is 4 plus root 15 in the numerator. In the denominator, you get under root of 16 minus 15, which is under root of 1. This is 4 plus root 15. Oh, that's pretty simple. That's pretty simple. This is 4 plus root 15 in the numerator. Therefore, tan x by 2 is 4 plus root 15. That is my answer for this question, as you can see, right? We have found cos x by 2, we have found sin x by 2, and we have found tan x by 2 as well. Rationalization of this here, and similarly cos x by 2 is something which you can do. I am hoping that you can do. The result would look something like this. In the denominator, you will get 2 times 2 is 4, and since you have multiplied root 2 and root is already there, under root of this will become 8 and into 2, this will become 2 root 15. Similarly, in the cos x, what you will get is 8 minus 2 root 15 upon 4, right? That's what you get. And that's all in this question over here. With this, we come to the conclusion of this miscellaneous exercise of trigonometric functions. Yes, this is the end of trigonometric functions chapter number 3 of class 11th mathematics. Remain with us for further updates, further videos based on NCERT Solutions. Also subscribe to our channel of Vyas Edification for these latest updates. Till the next session, all the best.